Okay, YouTube, in this video we're going to be looking at how to find the rational zeros of a polynomial function. And before we do so, what we're going to do is going to consider this, reading here it says, when finding zeros of polynomial functions, what kind of numbers can we get, And so they provide this really good example here, in my opinion, looks like 1, 2, 3, 4, 5, 6 factors being multiplied together. And you can see the variety of different types of zeros that we can get here. So in terms of zeros, first of all, because all of these factors multiply out to be the polynomial here, if we were to set this equal to 0, remember that we would set all of these individual factors equal to 0. And for instance here, if we set x plus 3 equal to 0 and solve it, we get x equals negative 3. So in terms of the types of zeros we can get here, you can see how the 0 is related to the factor here. They're kind of opposites, but we can get either real zeros or non-real zeros. And if you get non-real zeros, you can see that these types of zeros here are these complex imaginary zeros, these numbers in a plus bi form. But in terms of their factors, we're writing x minus this 0 and x minus this 0 up here for their factors. We could also get either, in terms of real zeros, we could either get rational or irrational zeros. So irrational, these are numbers like the square root of 2, because these are decimals when you write them as decimals that never terminate but also don't ever repeat, like 0.3333. So with respect to this video, we're going to be looking at rational zeros, these kind of zeros here, these ones that look like x plus 3 or 2x minus 1, these linear factors that get real results here that are rational. So the rational zero theorem is really the emphasis of what I want to talk about today, and it says the rational zero theorem provides us with the tool that we can use to make a list of possible rational zeros for a polynomial function. So the idea here is this: we're going to be given some f of x, and we're going to say, can we go factor this? And probably not on our own, but what we're going to do is we're going to try to find a factor that goes in evenly so that now we end up with this quotient here that is something that we might be able to factor on our own. So here's what we're going to do. We're going to say that we're just going to synthetically divide f of x until we find something that goes in evenly. But what this rational zero theorem does, when it says provides us with a tool that we can use to make a list of all possible rational zeros for this function, basically it gives us a list of numbers to try to use out here. Okay, so it's a list of possible, and I'm going to write this word here, rational zeros. So if you are a rational zero, basically, you're going to be on this list that we make here. So you'll read here, it says equivalently the theorem gives us all possible rational roots of a polynomial equation. So not every number in this list we make will be a zero of the function, but every rational zero of the function that exists is going to be on this list, which is the convenience here. So in terms of the rational roots theorem, let's take a look at what it says here. It says if you're a polynomial and your leading coefficient is a sub n and your degree is n, we say it has integer coefficients, so all of your coefficients here have to be integer values. You can't have a decimal. But if that's the case, then we say then p over q is a rational zero of f if and only if p is a factor of the constant term and a sub 0, which is the a sub 0 term here, pardon me, and q is a factor of the leading coefficient. So basically, we're going to make a list of numbers that are of this form, p over q. And everybody gets bent out of shape after reading this the first time. They're like, that's really confusing. But what we're going to say here is this: p represents all the factors of your constant term here, a sub 0. So we have a sub 0 factors. And we're going to list those over all the factors of leading coefficient, which are a sub n is our leading coefficient. So a sub n factors. And when we make this list here, you have to understand something, that a factor of something could either be positive or negative. So when we look at this down here, these two things, let's say for instance I wanted to go solve these and I noticed that I can't factor them, so division might work for me. So let's go ahead and make our list of possible rational roots that might work here. So one thing I like to do is just write RR, which is kind of a personal deal. And I write plus or minus, and then I write this little cusp. And what this represents is the set of numbers, including these. So the plus or minus out front allows us to write the factors of these numbers without having to write positive or negative in front of every single one. We can just list it out in front. And what we're going to do here is we're going to write this little bar here, and we say, what are the factors of the constant term? So looking at our constant term of 6, I say its factors are 1 and 6 and 2 and 3. And I like to list them in order here, so I'm going to go 1, 2, 3, 6. But those are all the factors of 6, and we say, what are all the factors of leading coefficient 1? And I would say just 1, are all of its factors. So what you see right here are all of the possible rational roots for this function. Now here's the deal. We need to rewrite this list, okay, once we get it in this form. And when we rewrite it, we're going to rewrite it in what we call roster notation, which is, kind of horizontally. And so what you see here is 1, 2, 3, and 6, but all over 1. So we're going to say 1 over 1, which gives us 1, 2 over 1, which gives us 2, 3 over 1 gives us 3, and 6 over 1, which gives us 6. And so you can see that these are all rational numbers themselves because I can put them all over 1, but it's a little bit easier to look at in this format here. So let's take a look at this next example. It says list all the possible rational zeros of this. Let's say I want to go solve this, and so since I can't factor it, we're going to list all the possible things that could potentially go into it evenly. So we say, all right, put our fraction bar. Factors of -3 would be a positive or -1 or plus or minus 3. And we put the plus or minus out front there. And then the factors of our leading coefficient are, 1, 2, and 4. So when we list this in roster notation this time, we're going to say, well, this is the same thing as, we'll just go through one thing at a time. So I suppose I would say that I would do 1 over 1, which is 1, 3 over 1, which is 3. Okay, so now we've done our 1 here. I would say I'm done with this. We're going to say 1 over 2 is next here. So we have 1/2 could possibly go in. And then 3 over 2, 3 over 2. And then go over our 4 here, 1 over 4 and 3 over 4. But we could list all of our possible rational roots this way. So if anything's going to work with this function and it's rational, it has to be included on this list. Cheers.